A linked list is a data structure composed of a sequence of nodes, and a node is composed of a piece of data and the memory address of the next node. But why use linked lists? Why not instead, use an array? Well, linked lists are better at scenarios when you don't immediately know how much data you're getting or that it's all coming in one shot or not. Let's look at an example, one where you're building a queue of songs. It's simple. A song comes in and you want it played in that specific order. Let's also, just for the sake of argument, use an array for this. It seems pretty straightforward. You define your array, you allocate however much space you feel is necessary for it, you populate it, and then iterating through each song, listening to each one. But what if you wanted to add more songs, even after you run out of space? Well, what you could do is make a new array with a bigger size, copy all of your song elements from A to B, and then keep on appending to the end. And this would be the code to do exactly that. Now, if you didn't want to do this manually, you could use the realloc keyboard instead of the regular malloc, and chances are you're actually able to get the same block of memory but just to the size you want. The worst case is that this will do exactly what we were doing previously. I'll show you why this is such a bad thing. Each time you want to make your array bigger, it increases exponentially in size over time. This doesn't make the space complexity O to power n, it's still very much On, but you're using, at the worst case, twice the memory for the amount of songs you'd actually need. And like we said before, you're going to experience an unpredictable O(n) spike in time just for adding another song. And what's more, say you want to delete a song anywhere. You'd manually have to shift all the songs afterwards up one by one, and that itself is an O(n) operation. Using a linked list can make this so much easier. All you need to do is do this to initialize your playlist, add your first song, add your next song, and then so on. Also, this head that you're seeing right here is just a way of keeping track of the linked list. Now let's talk about deleting a node. Let's say we want to delete this 2 right here. Well, to do that, we'd first take the previous node's next node, this one here, we make that next point to the current node's next node, and then if we have to delete it manually, we just go ahead and do that. Other similar operations like inserting a node in the middle, or shifting elements, or... Let's really briefly cover a way we can make the way we do this a little more efficient. Let's say we want to be able to play the previous song, then we'd add another field called prev or previous for pointing to the node directly behind you. And just for making the addition of a song a lot more efficient, let's also add a tail attribute over here to signify the end of the linked list. Linked lists are intrinsically dynamic data structures. Now, this has 2 implications. The first of which is that you always have to free what you malloc once you're not using it. The second, of course, is that while a linked list might intuitively look like this, it actually looks something more like this in memory. See, with arrays, we have the benefit of being able to calculate the address of any element because it follows a certain mathematical pattern. But we just don't have that with linked lists. That's why if you want to look up a node or do anything else, what you're going to have to do is walk through every single node to get to the one that you want. This gives a lookup time of O of n instead of O of 1, and our space complexity, of course, remains the same. But this gives us a benefit that we just don't have with arrays, really. Any operation takes a relatively predictable amount of time, and we don't waste any space. The point is that a data structure is nothing more than a tool. They've got advantages and disadvantages, trade-offs over the other, and it's not limited to just linked lists or arrays. It is everything. It is hash maps, it is trees, it is virtually any data structure you can think of. You just need to pick the one that fits your use case the best.